The Mechanical Products Bussman Minibreaker is an older product, not widely available anymore. However, there is some information available regarding its trip curves. The Minibreaker came in different current ratings, including 5 amps, 10 amps, 15 amps, and 20 amps. The Minibreaker's trip time characteristic is inverse time current, meaning the trip time decreases as the fault current increases. The pre-arcing time of the Minibreaker is approximately 3 to 5 milliseconds. The arcing time is typically less than 1 millisecond. Here are some approximate trip curves for different fault currents. For a 5 amp Minibreaker with a 5 amp fault, the trip time is 100 to 150 seconds. With a 10 amp fault, the trip time is 10 to 15 seconds. For a 10 amp Minibreaker with a 10 amp fault, the trip time is 50 to 75 seconds. With a 20 amp fault, the trip time is 5 to 10 seconds. For a 15 amp Minibreaker with a 15 amp fault, the trip time is 30 to 45 seconds. With a 30 amp fault, the trip time is 2 to 3 seconds. For a 20 amp Minibreaker with a 20 amp fault, the trip time is 15 to 25 seconds. With a 40 amp fault, the trip time is 1 to 2 seconds. It is important to understand that these trip curves are approximate and can vary slightly from the actual performance. Also, keep in mind that the Minibreaker is an older product, so its trip characteristics might have degraded over time. Therefore, it is recommended not to rely solely on these trip curves for circuit protection purposes. Consider the age and potential degradation of the device when using this information. Always prioritize safety when working with electrical systems and consult with a qualified electrician if needed. Newer circuit protection devices offer more reliable and predictable performance characteristics. If you are looking for replacement options, consider modern circuit breakers or fuses that meet current safety standards. These devices offer improved accuracy and reliability in protecting electrical circuits from overcurrent conditions. Before replacing any electrical components, it is crucial to energize the circuit to prevent electrical shock. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, when working with electrical systems. Always follow the manufacturer's instructions and local electrical codes when installing or replacing circuit protection devices. Proper installation and maintenance are essential for ensuring the safe and reliable operation of electrical systems. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents and injuries. Remember that electrical codes and standards may vary depending on your location. Be sure to familiarize yourself with the applicable codes and standards in your area before performing any electrical work. Regularly inspect your electrical system for any signs of damage or wear. Replace any damaged components promptly to prevent potential hazards. Over time, electrical components can degrade due to factors such as heat, humidity, and corrosion. Regular inspections can help identify potential problems before they lead to failures or safety issues. When selecting circuit protection devices, it is important to consider the specific requirements of the circuit being protected. Factors such as voltage, current, and interrupting capacity should be taken into account. Using the wrong type of circuit protection device can result in inadequate protection or even damage to the electrical system. Always choose circuit protection devices that are appropriately rated for the intended application. If you have any questions about selecting the right circuit protection device, consult with a qualified electrician or electrical engineer. They can help you determine the appropriate device based on the specific requirements of your electrical system. In addition to circuit breakers and fuses, other types of circuit protection devices are available, such as surge suppressors and ground fault circuit interrupters, or GFCIs. Surge suppressors protect electrical equipment from voltage spikes, while GFCIs protect people from electrical shock. Consider using these devices in addition to circuit breakers or fuses to provide comprehensive protection for your electrical system. Regular maintenance of circuit protection devices is essential for ensuring their proper operation. This may include testing circuit breakers to verify that they trip properly and inspecting fuses for any signs of damage. Follow the manufacturer's instructions for maintaining your circuit protection devices. If you are unsure about how to maintain your circuit protection devices, consult with a qualified electrician. They can provide you with guidance on proper maintenance procedures. When working with electrical systems, it is important to be aware of the potential hazards and take appropriate precautions. Electrical shock, arc flash, and arc blast are all potential hazards that can result in serious injury or even death. Always de-energize the circuit before working on it, and use appropriate personal protective equipment. If you are not comfortable working with electrical systems, it is always best to consult with a qualified electrician. They have the training and experience necessary to perform electrical work safely and effectively. Electrical safety should always be your top priority when working with electrical systems. By following safe work practices and taking appropriate precautions, you can minimize the risk of accidents and injuries. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical safety. They can provide you with the information and guidance you need to work safely with electrical systems.